Welcome back, guys. You can see I've got the other Z-axis lead screw in, coupling nut, and these little nuts here are not set up completely yet. There should be a notch on the side of the coupling nut that this would go into and just bite in to stop it for sure from moving around. Same with the other one here, it's not fully in. Got the bushings straightened out. Something you're going to notice right away, besides having that stepper motor added, and one of my tests for a coupler, I gotta remember I can't just turn that because it's connected now. The X-axis motor's on. Here, I'm going to have to get that light again. See if I can do this the old way. Probably not. It's going to bump you around for a minute, guys. So we got the X-axis motor there. It has the belt. You can see. And instead of putting bolts through, and the headache that was going to be, I remembered that zip ties are pretty darn strong. Not only that, the belt puts compressive tension on this joint anyways, so that's pretty solid. The zip ties hold alignment because they're 3 mils. 3 mils on the zip ties keeps the holes in line, but the tension on the belt actually pulls this on harder. And we're just gonna, we'll come back to him in a second. Over here we have the belt tensioner, and you can see here I've also done the same thing with the zip ties. Hopefully this is recording me properly. Down in there we have the belt over the pulley, and here, making too much of a shadow on myself. Yeah, you can see I forgot to put the metal plate to protect the plastic, but the plastic's pretty tough. This is the simple extra tensioner. You just put a pair of needle nose on that and turn this, and you can tension that because this, in theory, moves that way. I can't do it with just bare hands. A little bit. That pulls on this whole structure, which pulls on the pulley, which tensions this belt. Now I don't have it under full tension, I have it pretty close. And this, I'll see if I can spin it around, is a printed block with teeth in it that match the timing belt, and some standoffs that are actually going to grab into whatever I make for the X carriage. Because I wanted to make the X carriage changeable for this experiment, I wanted to make sure that the connection was really simple. So this system here holds the belt perfectly strong and allows me to change it out. Now I'm probably going to make a version of this to work with the bed down here. What the X carriage is going to run on are these, I don't know if this will focus, maybe. Hang on a second. You guys went for a little ride. There are these small V-groove bearings, and of course they ride perfectly on the top of that. Now the other configuration is to use the regular bearings, or even V-grooves again, 4 of them or 3 of them, to ride on the sides of the aluminum, and I might try that as well. But I think the first we're going to go for simple 4 bearings, top and bottom, like that. Now, the other thing is, remember before I said that sometimes the rails can be pinched in a little bit? Well, that's gone away quite a bit since I've added the M3 screw that comes up through the middle and then has a nut on top here to apply clamping force. There's much less flex now, but I could still print, with the clearance of the belt is pretty good, I could still print a C-shaped piece of plastic that would go in the back here and support the bottom and the top in the middle and would stop it from getting pushed in. But it's pretty tight. I mean, I'm pushing in with almost probably more force than I did the first time, and I'm getting hardly any deflect. Yep, hardly any motion. I'd have to push a lot harder, and that might break something, so we're not going to do that. But anyhow, I'll put the file up on Tinkercad for this belt clamp. It's probably not going to work for everybody, but it'll work for my situation here. Wanting to keep as much of this stuff modular as I can. Next is, in the theme of recycling, and of course it's not here, I printed a test stepper motor mount a while ago, and I just come to realize it's going to work perfect for here. And it was an earlier version of one of these that had a more box style or conventional holder, and I'll put a link in the video to where I've tested it, because that motor over there used to be mounted in it, and I used it on the table upstairs, showing the stepper motor turning with the coupling nut. So what it'll do is it'll probably mount on the front here, and I will have the belt looping in this fashion instead of over like this, like a sort of like a tank track or a tire would be. I'm going to put it this way, kind of like how the Fabricator Minis is. And there's going to be a bigger version of this, or a version of this with a hole in it. This bolt will go in, and then a couple nuts will tighten it up, some spacers in the nut, or I'll just print a PLA spacer. We'll tighten that, and then the bed will be moved by this bolt. Okay. And then at the back will just be an idler, and again, just a couple bearings holding that, and probably I will have a big metal washer, and it might just be as simple, a big metal washer, it might just be as simple as a bolt down through this wood, with a washer on both sides to keep the bolt and the pulleys perpendicular to the plane of this piece of wood here. And there's also the possibility that I'm going to get that hole cut in here, as I mentioned, for doing the attachment. I'm not sure about that yet, so I haven't even penciled it on that. But anyhow, that's where we are with this. I could almost test run the X and Z axis in one run. For those of you that wonder, I'm Canadian, but I have a lot of American friends, so you're going to hear me say Z, Z, whatever I last heard is probably what I'm going to say. So any of you guys out there that get bugged by either way, you're going to hear it both ways. Another quick note, yes, I talk mostly in metric, but I will pop over into standard and imperial from time to time. I don't convert them well in my head. I learned both, so to me, I may not convert them, but I'll use them as long as I get the job done, right? Anyhow, back to this. You may have all seen how the bed goes on that. I do have a piece of borosilicate glass coming. I do have a glass cutting wheel, a proper one, and I'm going to still give a crack at, wrong choice of words, I'm still going to have a go at trying to cut my own piece of plate glass for that, because, you know, glass in the mail, it might not get here in one piece, right? Anyhow, so that's that. That's an update on this. Probably went a little further than I meant to, but there's a few things to talk about. So if you have any questions or that, don't hesitate to put them below. For those of you that are asking for the Tinkercad parts for these things, as I finalize them, and they're getting pretty close, I will put the whole project available. There was some changes with the Tinkercad and Tinkercad Beta coming out that it almost broke my original work file. So I'm going to be very careful. I probably won't even open that file for a little bit until I test my other ones, because some of the community objects had disappeared and I didn't want it to potentially destroy my project. But once that gets settled down, I will make all the PLA parts public. So if you want to have a go, or you just need to make a custom 8mm rail holder, I did make a video on how to make these, but if you wanted to just grab these, go ahead. The same with this. It's all pretty straightforward. You can print the motor mount, print this off, and then just adjust the height as you would need as a standoff. All that stuff is going to be there. Anyhow, as always, thanks for watching, and I'll see you in the next video.